I'm here to introduce to you a methodology that helped me through the many years of practice as an IT specialist. The methodology started from a challenge I did in Singapore when I spoke to the Singapore Computer Society on the topic of systems analyst wrong approach. For many, in fact to all persons, it came as a shock because can you imagine systems analysis approach is the Bible of the computer people in order to solve problems. And there I am, the #1 critic on how it's used. After our lunch business meeting, a CEO friend invited me to conduct an impromptu lecture within the hour with his management team. He asked me to explain to them my innovation, which I call Data Blueprint, as a tool to define system specifications. His firm represents a multinational company that handles corporate business data, and typical of small and medium organizations, it relies on spreadsheets to handle their billing, procurement, disbursements, and general accounting processes. Among those present in the meeting were the heads of finance, marketing, and production. The IT officer was there too, along with a programmer. I started the talk by asking the IT head, "How long will it take you to develop an accounts receivable system?" He replied, with the full authority and conviction of a seasoned practitioner. "Based on our requirements, 6 months." I looked at my friend, the CEO, and said, "How about 6 days?" Then I wrote this on the lecture board. To explain what I had written, I said, "The message I wish convey is that in the history of systems development, the bulk of cost consists of discussions, rigorous documentation, testing, clarification of specifications, as well as the attendant wrangling and misunderstanding among those involved. Worst of all are the never-ending changes and modifications to the systems. I advocate reducing this 90% cost to a reasonable 10%, so that the total cost of system development goes down to only 20%, as compared with current practices." I then asked the head of finance, a lady who was introduced as a seasoned CPA, to define their reporting requirements for a receivable system. She enumerated the following: accounts ledger or statement of accounts, sales registry book, cash receipts book. She proceeded to identify the source documents upon which accounting inputs were based: invoice, official receipts. As she was verbally enumerating the reports and the source documents, I was formatting the requirements using a matrix in the board. I started with the customer ledger and asked her to enumerate the fields used in the report. These are the customer ID, name, address, balance forward, debit amount, credit amount, and the transaction document number. As she was enumerating those fields, I wrote a Y across the corresponding field. Then I asked, what are the inputs used to prepare the ledger? Then she enumerated 2 basic forms, namely the sales invoice and the official receipt. So based on her inputs, I added 2 columns in the handwritten matrix and simply put a yes on the fields they represent. The next question I asked her was, what are the usual reports or listing done by the bookkeeper to account for invoices and official receipts? She replied, they are the sales registry report and the cash receipts book. My comment was, wow, that is half the task that general accounting is responsible for. She readily agreed with me. Then I added the title visual specs to summarize what usually represents the user's requirement specifications. At this stage, I said congratulations. As the user, you have defined the core or visual requirements of the basic accounts receivable system. At the moment, while it seems that is all that is needed, There may still be some items missing from the requirements you have defined. Do not worry. Within the 6 days allotted for systems delivery, the programmer will surely be able to identify them all. Furthermore, should there be major items that may have been overlooked, it will surely show up upon systems testing. The methodology is self-correcting. The above are the mandatory or must-have of the Accounts Receivable System as perceived by the finance officer. If one will evaluate basic requirements against the popular accounting products, the functionality is similar. I then turned to the IT head and the programmer, and we proceeded to translate the visual requirements defined by the user into virtual specifications, which those who are computer savvy easily understand. I asked the programmer what data entry forms are needed. He quickly responded, "Sir, we need data entry form for the invoices and official receipts in the statement of accounts." The programmer was no neophyte, judging by his speedy reply. So based on an imaginary data entry form, I assigned on the board columns for these data entry forms, with invoice written as FRMINV, official receipt as FRMOR. The programmer dictated entries on the rows, such as Y on ID cust, D on name, D on address, Y on date, Y on D amount of invoice, CR amount of OR, and Y for document reference number. I did not bother asking about the required customer data entry to save time for the users present. I was certain that the programmer or his IT boss would eventually add this required data. I asked, "Where do we store the encoded invoices and official receipts?" Again, a fast response from the programmer. The encoded documents would require disk space to store details. Therefore, tables are needed for the following data to be called: TBL invoice, TBLO receipt, and TBL client. Note: table is the term used to identify an electronic file. Table names are prefixed with TBL to indicate that the file is a table. TBL client, although not earlier defined by the finance officer, was defined by the IT practitioner as essential to the database in that it identifies the client's name and address. It was noted that the client's name and address can be taken from the customer enrollment form. Thus, it was necessary to add that source document among the inputs. Consequently, another data entry form, to be known as FRM client. As we were enumerating the above database, I added more columns to the matrix. Any responsible officer of the firm can formulate the visual system specification. On the other hand, the IT head and his staff should be able to translate such specifications into its virtual system counterpart. This is how virtual system specifications evolve. It does not require rocket science to come up with it. Given clear and concise definitions, an experienced programmer will be able to create the tables, design the data entry screens, and code programs within 6 days. One of the participants in this short exercise observed that the matrix I illustrated is a practical approach to systems design. Clearly, both users and technical staff have together decided on and agreed upon what the system's specifications are. They have also decided on who is responsible for what. This approach forestalls misunderstandings. Being self-correcting, the probability of errors and omissions are greatly minimized, along with the blame game that goes with it. Still, in another session that I handled, the finance officer, who brought her accounting staff to meet with the IT team, said, "Sir, they will not quarrel anymore." Upon finishing my talk, I requested for a cup of coffee, which my CEO friend personally prepared for me. He was so happy and grateful to me because it is very simple to use and could be applied against future problems. Note There is a difference between the handwritten matrix on the board against the refined worksheet documented by the programmer. It is the TBLBALF, where the details of invoices and OR, the accumulated balance forward status of the client's receivable. This correction is intuitive to an experienced programmer. The other resource could be his IT head, who is expected to detect the oversight. If both are neophyte and doing basic ledgering programs, since this is not commonly taught in school, they will eventually derive the table using common sense and discovery by trial and error. This is, of course, will take long hours, even for experienced analysts or IT. As a bonus, I also explained to them that they can come up with an accounts payable system in a third of the time needed, since the flow of logic is the same. All the programmer needs to do with the data entry and ledgering templates is change the titles, forms, tables, and data fields. That effort is a no-brainer, being practically clerical in nature. This matrix format is what I call the data blueprint. From a systems design perspective, data blueprint is clear, concise, and easy to use for both the user and the IT or programmer. Lessons learned. In the previous example of defining system specifications for a typical business application, such as accounts receivables, we can conclude that 1. Systems development man-hours can be shortened similar to the old days of rapid delivery system. 2. A simple way of documenting specification is adequate and easier to update and understand. 3. Any office head or system user can accurately define their system's requirements using a simple form. 4. Errors or omissions shall be discovered and corrected during programming and testing. 5. Even with a short delivery term, the benefits to the user is substantial since the core problems of delays is addressed. 6. Ownership and control of the system rests with the users, who are forced to limit requirements to bare essentials. You've witnessed the remarkable effectiveness of the data blueprint methodology in streamlining the development of the accounts receivable application, a pivotal component within an ERP system or enterprise resource planning framework. Building upon this success, we are poised to extend the application of the data blueprint methodology to optimize the following critical business functions within our ERP system: accounts payable, treasury system, and inventory management system.